These are the 4 multiple choice questions that have to do with area and region. So this is question number 1, and it's telling you that you have the graph of y equals ln x, that's in pink, the line x equals e, that's in green, and the x-axis, which I'll make in black. And so you're looking for the area that's enclosed by those 3 graphs, and that would be this piece right here. And cross-sections are perpendicular to the x-axis, so that means that we're going to be talking about an integral of the area of the cross-section, dx, because it's perpendicular to the x-axis. So all we need to do is to find the area of the square. So the area of a square is just going to be the side squared, and so now you have to figure out what is the length of the side. So if it's perpendicular to the x-axis, it would be like this purple line here. So the height of that side is going to go from the pink curve down to the black line, so that's just going to be ln x minus 0, so that it's really just ln x squared. So then you go back to your integral, and we're just going to have ln of x squared dx. And now you just have to figure out what's the lower and upper limit. So this picture is going from here to here. And you know that the second part is e, because they said it's going until x equals e. And then you just need to see, where does the pink line match the black line? So the pink line is ln x, and where does that meet the black line, which is 0? So the only thing that would make sense for this is if x equals 1, because ln of 1 is 0. So I can put that 1 in here in my integral. This was a calculator question, so you're just going to put that into your calculator, and you should get 0.71828, and that was choice A. Okay, this is question number 2. Oops. And this is what the picture looks like. So we're only talking about the first quadrant. There's this one, the yellow picture is y equals 8 minus x to the 3 halves. And then you have the x-axis and the y-axis, so you're talking about this piece right in here. So we're looking for volume going around the x-axis. So this is going to be pi, the integral of the top squared minus the bottom squared dx. And now we just have to fill stuff in for that. Okay, so for the limits, we're going to be going from 0 to wherever the yellow function meets this like olive green function, which is just 0. So if you set 8 minus x to the 3 halves equal to 0, you get 8 equals x to the 3 halves. So the easiest way to do this is to multiply both, is to multiply both sides by an exponent of 2/3, because then you'll see that these will cancel and you just get x to the 1, which is x, and this becomes the cube root of 8 with the power of 2. So the cube root of 8 is 2, and 2 squared is 4. So that's my upper limit. Okay, the top function is the yellow one, and the bottom one is just 0. So I don't even really need to write that in there. So you're going to put this into your calculator. And when you do, you should be getting pi times 115.2. But all the choices are in terms of decimals, so you're actually going to go ahead and multiply that by the pi key on your calculator, and you should get this. And that is choice E. Okay, this is question number 3. And so you have the graph y equals x squared, which is just this red parabola. the line x equals 4, which is that green line, and then the x-axis. So you're talking about this piece in here. Okay, and we want the volume as it goes around the y-axis, so it's going this way. So that means we're going to have pi. Your limits will be in terms of y. It's going to be right squared minus left squared dy. And now we just have to fill that in. Okay, so the smallest y is 0, and then you have to figure out what's the biggest y. Well, the biggest y is happening right here at that black dot. That's when x is 4. So if you put x equals 4 into x squared, you'll get that y is 16. This is the point 416. Okay, the function on the right is 4 squared minus the function on the left. The function on the left is the parabola, which is x squared squared. And you can see right away that there's a problem because you can't mix x's and y's. So we have to take this out of here. It's a little bit of work. So if y equals x squared, then if I take the square root of each side, I get that x is the square root of y. So I'm going to put that in there. Square it. So if you simplify this, you get 16 minus y dy. And you can either do that by hand or put that in the calculator. But you'll get pi times 128. So that gives you 128 pi, and that was choice B. Okay, for number 4, you have the graph of y equals e to the negative x. That's this one over here. And you also have y equals e to the x. That's this one over here. And then the line x equals 1, which I'll draw in right now, which would be somewhere like that. So we're talking about the region that's right here. This little gold region. Okay, so we're going to revolve around the x-axis, so that means we're going to have pi. We'll have our limits in terms of x. It's going to be the top squared minus the bottom squared dx. Okay, so first of all, to find the limits, they meet at 0, and you know that meets at 1 because you were given the function x equals 1. The function on top is this one right here, y equals negative x. I mean e to the negative x. So it's e to the negative x squared minus the bottom, which is just e to the x squared dx. You didn't have to solve this, you just had to look to see which one it matches. And so if you look at your choices A, B, C, D, and E, you can immediately eliminate A, B, and C because there's no pi in front of it. And you have to have pi there for the volume. And then so if you look at choice D and E, it doesn't match either one. But if you simplify a little bit, remember there's a rule that says that if you multiply an exponent to an exponent, if you have an exponent to an exponent, you just multiply them. So that would give you e to the negative 2x minus e to the 2x dx. And that one matches D. Okay, wait, that does not match D. So I screwed this up because I didn't copy what I wrote down on the paper and I just did it as I was doing it. The top function is actually e to the x. Here, if you look over here, this is the top, and that came from e to the x. Sorry about that, so we'll just fix this. Take out this negative. It's a good learning lesson for you. So this is going to be e to the x squared minus e to the negative x squared. And so I'll just fix this up here a little bit. So this becomes e to the 2x minus e to the negative 2x. and that does match D perfectly. Okay, so that's it for these. Yeah, that's it.